Okay, so today we are going into section 4.1, which is exponential functions. So exponential functions. Now, in the past, we've looked at stuff like, that. X squared, which looked like that, basically, or we had stuff like x cubed, which looked like something like that, or whatever. But we're not going to do that anymore. Now, these are polynomials, remember? These were polynomials. They had the x in the bottom, right? Make that darker. They had the x in the bottom, and they had some kind of a number in the top. Well, we're going to focus instead on exponential functions. And exponential functions, instead of having an x on the bottom and a number on the top, they have a number on the bottom, like 2, and an x on the top. So here, the number's on the bottom, and the x is up there on the top. And the x is on the top. So number on the bottom, x on the top. Exponential functions are any function in that form. Usually we say b can't be 0 or 1 because that makes it uninteresting, but pretty much anything besides that can be an exponential function. So we're going to start off by actually graphing one of these so you can see what it looks like. And we want to graph it by hand because I really want you to get this in your head once. And we'll graph it by hand once, we'll graph it in the calculator again if we ever need it. But first I want to do a quick review. Make sure you remember these. They're on your pretest. Review, they're part of the prerequisites for the class. I still can't spell. Let's try this again. R-E-V-I-E-W. I did it. Alright, so maybe you remember if I have something like x to the first. What x to the first is? Probably, hopefully, x. Just x to the first is just x. X to the 0 is, where x to the 0 is 1. What x to the negative 1 is? Remember the negative exponent here? That means we flip it. So x to the negative 1 is really 1 over x. A more general version of that is to say that x to the negative a, if we have that negative exponent, it means that we're going to go with x to the a, 1 over x to the a. Basically, the negative sign in front of the exponent means that you flip it, and you can get rid of the negative sign after you flip it to the bottom. Alright, that should be good to get us going. So I'm going to graph an exponential function. So let's graph the one that we just wrote. So we want to graph f of x equals 2 to the x. So I'm going to do my little xy table. And I'm going to go with -3, -2, -1, 0, 1, 2, 3. All right. So let's start at the bottom and work our way up. If I've got 2 to the x, when x is 3, that means I'm going 2 to the third. 2 cubed, that's, in case you're forgetting, 2 times 2 times 2, which is 8. All right. Then for the squared, I've got 2 squared, which is 4. I've got 2 to the first, I can do this, 2 to the first, which is 2. Then I've got 2 to the 0. What 2 to the 0 is? Please tell me, remember, it's right here, 2 to the 0. Something to the 0 is 1. Anything to the 0 is 1. Alright, now I've got 2 to the negative 1. Right, 2 to the negative 1. Anything to the negative 1, we just flip it. So 2 to the negative 1 is going to be 1/2. 2 to the negative 2. Remember? Again, we see that negative sign. So that means we flip it. So 1 over 2 squared, or 1/4. And finally 2 to the negative 3. The negative sign means I flip it. So it's 1 over 2 to the cube, which is 1 over 8. So basically, we've got here points at, come over a little bit. We've got points at -3, 1/8, -2, 1/4, -1, 1/2, 0, 1, 1, 2, 2, 4, and 3, 8. Like that. Now, here we go. I'm gonna plot this thing. I'm gonna go something like 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. All right. So I'm gonna start plotting my points. So I've got -3 and an eighth, which is like kind of tiny down there. -2 and a fourth. -1 and a half. 0, 1. 1, 2. 2, 4. And 3, 8. Now, as you make this connection, as you can see, our numbers here are 2, 4, 8. So what do you think the next number is going to be? 2, 4, 8, 16, 32, 64, 128. Basically, the number doubles. Every time we go out one this way, it doubles that way. So the smallest increase left to right makes or to the right makes a super huge increase going straight up. So what we can say is if we start here, we're going to go this way. We're going to go up. I got really good until the end. We're going to go really, really fast and go up super, super fast. The same way going the other direction, you can see here we have 1/2, 1/4, 1/8. So the number on the bottom is doubling. So I've got 1/2, 1/4, 1/8. So I'm going to have 1/16, 1 over 32, 1 over 64, and I'm going to keep getting smaller and smaller and smaller. But I'm always going to be greater than 0, right? Because even the smallest number, 1 over whatever, is still going to be greater than 0. It's always going to be positive. So this goes out this way forever and ever. And this is called, like we said, an exponential function. Now, if you're going into science, you're going to see this all over the place. We model all kinds of things with exponential functions. We model population. So I don't know if you've ever been to a family reunion where it's like you've got, grandma and grandpa, just like right here. And then there's like, they had like 2 kids, and then they got married and had 2 kids who also got married and had 2 kids. And then they got married and had 2 kids. And like all of a sudden, if you have like 4 generations, you've got like a bazillion people at your family reunion. You're like, how did this happen? You only have 2 kids each, but a lot of us have families that are like, they've got 3 kids, and then this guy had 5 kids, and then each one of them had a bazillion more kids. That's exponential growth. So population is always exponential growth. On the reverse side, disease is also exponential growth. So like if I sneeze on you, you go sneeze on 2 other people, and they go sneeze on 2 other people, now like the whole school is sick. If you ever saw that movie, the Pay It Forward movie, this is a goofy example, but it's true, with Haley Joel Osment was like, I'm going to be nice to like 3 or 5 people, whatever it was, and then if they're each nice to 5 people, and they're all nice to 5 people, then it's going to impact the whole world or whatever. That's exponential growth. So this is exponential, I'll write that out, exponential growth. You can also see exponential decay. They call it exponential decay in like radiocarbon dating. So if you've ever done that in biology, where they'll say, like after a certain number of time, half the carbon's in there, and then half the carbon's in there again, and then half the carbon's in there again. That's what we got here. We got half the carbon, and then we have half the carbon, and then we have half the carbon, and half the carbon, and half the carbon. That's exponential decay. So exponentials are very, very representative of what's going on in nature, which is really kind of cool. So you can do all sorts of stuff with it. In business, something else that models growth exponentially is interest. So compound interest. So you'll see these graphs that say stuff like, you know, if I invest, you know, like starting at age 20, if I invest, you know, $100 a week forever, but say if I do it between the ages of 20 and 30, I'll make like this much money, and then I'll continue to make money even if I never invest again. So like if I want to retire at $1 million or whatever, something like that. But on the other hand, they'll say, well, if you start investing at 30, you can invest every single year. So this is the amount of time that I'm actually putting money into the account that I never put any more in. And I'll say, well, if you're 30 and you start investing the same amount, it doesn't matter. Even if you keep putting the same amount in all the way out to the time that you're like 50, you're still not going to make the same amount of money. And that's because here you had an extra 10 years of compound interest. And compound interest, again, like I said, it models exponentially. So the sooner that you start compounding interest in your life, the better off that you're going to be insofar as retirement and all savings and all that kind of stuff. So it's actually pretty cool. It's very, very applicable. Pretty much no matter what you're going to be doing, it's very applicable. Want to make sure that you can use your calculator to do these, because you might be using some buttons that you've never seen before. So see if you can get these. Go to 3 to the 1.6, try 7 to the square root of 5, try 8 to the negative 1.2, and e to the 2.6. Now, as you're doing that, you got your calculator out, your book is actually going to say to round these to 3 decimal places. So we'll do that too, just to make sure you're prepared. Round to 3 decimal places. Okay? So if you don't have your calculator out, you keep it going. So what you're going to look for is you're going to use the to the button. It's the exponent button, the little caret. 3 to the, I always say to the because it's fun and it makes me happy. 3 to the 1.6 is 5.7994546. Okay, so 5.79954, and we'll just leave it. We'll come back and round it in a second. All right, so let's go to 7 to the square root of 5. The purpose of that is just to make sure you know you can combine these square roots and exponents all together. It's completely legitimate, although not necessarily as fun as it could be. All right, 77.57051, 77.57051, and we've got 8 to the negative 1.2. Remember, you got to use this little negative sign right here. So 8 to the negative 1.2, 0.082469, 0.082469. Now this one's E. You're like, what's an E? In any given class, only maybe 5 out of 30 have ever used an E. So if you haven't seen an E, there's this little LN button, which means natural log. We'll get into that soon. But above it, at least on mine in blue, is the E to the X button. If you're using another calculator, E to the X button might be over here. You're just going to have to look for it. It's probably going to be in small print above another button. So I'm going to go second, E to the X. Notice it already puts the caret and the open parenthesis in there for you. It's kind of nice. So I'm going to go E to the 2.6 and close off my parenthesis and enter. So we've got 13.46373. 13.46373. Right, now I'm going to do the rounding. So make sure you know how to round. So I'm rounding it to 3 decimal places and count 1, 2, 3, circle the 4th one. Remember, because it's a 5, maybe you round up on 5, 6, 7, 8, 9. And then you could say round down, but I'll just say otherwise, you know, get rid of whatever's left. So since I have a 5, that means I'm going to round up. So the 9 rounds actually up to a 0, and then that 9 rounds up to another 0, so that goes up to an 8. Another way to think about it is to think that the 799, if I add 1, I'm going to get 800. So that's actually here going to round up to 5.800. It's important to include all those zeros because you are rounding to 3 decimal places. So you want to show, hey, you know, I really did look at this. It does go all the way out. So our next one, we go count 1, 2, 3, circle the 5. It's going to round up. This one's a little bit more straightforward. So 5, 7. Since it's a 5, I'm going to round up. So the 0 is going to become a 1. Oops, that's not what I meant. So 5, 7, 1. Okay. Then we've got here, we start counting at the first one. Even though that's a 0, we still start counting at that first digit. 1, 2, 3, circle the last one. All right, that's a 4. So I'm just going to get rid of all that. And write 0.082. That's my 3 digits. And then finally, first, second, and third. There's my 7, so I'm going to round up because it's greater than 5. And so that means my 3 rounds up to a 4. So I've got 13.464. And that should be enough to get you started. Well, not on the whole assignment, but at least on using your calculator.